Hi, everyone. This is Ray Phillips of Precision Driving Analytics, and I hope everyone is staying safe in this whole COVID-19 crisis. Um, Today, I'm going to share with you my fourth video in the series, Going Beyond the Squiggly Lines. And today I'm going to talk about friction circles and combined Gs. So on my screen here, I have a friction circle, and you may notice that it may be opposite of what you're usually looking at. A lot of times the friction circles are upside down compared to this. But if you don't know what comprises a friction circle, it's simply your lateral G's on the x-axis and your longitudinal G's on the y-axis. So the reason why I look at friction circles in this manner is because I want to visualize where the G forces are. So for example, if you're braking, then the G forces are going up, right? So, you're going to feel those G forces and you're going to go forward in the car. So that's why I like to have braking going up. And of course, acceleration would be going down, because as you accelerate, you're pushed back into the seat. And as you take a left-hand turn, G forces are going to be on your right. So in this quadrant is going to be left-hand turns. And as you take a right-hand turn, of course, the G forces are on your left. So in this quadrant, that's all G forces from right-hand turns. So this is why I like to look at G forces this way. But there's another reason, and I learned this from a very good data engineer, a guy named John Block, owns AutoWare Inc. And he's got some great webinars going on, by the way. And if you want to learn a lot more about data analysis, those are very good webinars. But anyway, let's get back to another reason why I do this. So at the top here, we have longitudinal G's in yellow, and we have combined G's in blue. So if you don't know what combined G's are, I'll pull up the math channel for you. It's a pretty common math channel these days. So what it's doing is, and it's right here, it's combining the lateral and longitudinal G's, and it's taking each one of those, lateral and longitudinal, and squaring them, and then adding them together, and then taking a square root of that product. So what it tells you is, it kind of gives you a better understanding of the potential grip level of the car. In this case here at this corner, this is Homestead, by the way, pull up a track map. So driver's approaching a right-hand turn, and he's had a little bit of time to accelerate here to a decent speed. This is a Ferrari Challenge car. So as he brakes, the driver is reaching. Let me get rid of those videos so that we can see those. All right, so he's reaching about 1.5. I think he gets up to 1.6 or so G's there. Yeah, almost 1.6. And then as he's slowing the car down, the G forces are dropping off. I'll show you here how they drop off here, and we'll expand this a little bit. So you can see the G forces are dropping off, and then he goes into the quartering phase, and they build up a little bit again, but they're not higher than what the driver experienced longitudinally. So, my first question would be, well, why not? Is the track off camber there? Is there something preventing the tires from doing it? Because clearly, if we see over here, the driver also decelerated. but then the G-force is built up, and there's a big bump here, so that's why you're seeing these big spikes. But really what you're looking for is kind of a tabletop um, of sustained G-forces. And you can see a little bit here. If I zoomed in, you probably see a little bit better. So you can see how that kind of flattens out. So now he's got a tabletop of kind of consistent G's, combined G's. But again, my question would be, well, why aren't these combined G's higher than the longitudinal? If you look at his friction circle down here, we'll move this back up. You can see the drop, from the braking to acceleration and then into the cornering. So, this is potential time on the table. If the driver could make this more of a half circle and join it to the top there, then that would obviously be more lateral G's and longitudinal G's combined. And the driver's going to take time off the clock because he's pushing the car harder through that corner. So I really like using this when analyzing data because it's pretty easy to see where potential time is. Now, doesn't give you all the answers. Maybe there's a setup change required. Maybe the track is a little different at some spots where the driver can't maintain those combined G's, but gives you a good starting point. The other thing I like to do with the friction circle is have some math channels, trying to get this thing to expand. Actually, I'll just do this and we'll get rid of the map. So the other thing I like to do is have these half circles show up. So what these are is the top one is 1/2 G's, the bottom, the middle is 1 G, and the bottom is half a G. And again, I'm using AIM RS2 analysis here. And unfortunately, AIM doesn't have a null value function. So this will only work if you're using dots or circles. So if I go to my settings and change this to lines, which is actually a lot of times very helpful with friction circles, you'll see that these lines, go spiking up again because I can't give a function that says, well, only give me the lines if there's G values, and when there's not G values, just give me a null function. So if I could do that, then I could use the lines and not have these lines spiking up. But let me show you the math channel for these. So the way you create these is basically just taking the calculation of a circumference of a circle. So we'll look at 1/2 G's. So 1/2 G's is going out here. So that from 0 to 1/2 on either side, that's effectively the radius, right? So our radius for the circle is 1.5. And inside here, we're squaring that. And then we're subtracting the lateral accelerations squared, okay? And then we're taking the square root of that, and that gives you these half circles. So if you want to go look up, the calculations for a circle, then, then that'll probably help you understand this a little bit better. But if you want to just use that math channel, then you don't have to worry about it. Okay, so there you have it. Hopefully you find this helpful. And by the way, through the end of April, all my remote services are 35% off, and all the proceeds that I receive from the purchases are going to go straight to the Durham Rescue Mission, which is in Durham, North Carolina. They're one of the food banks in our area. So, I figure it'd be a good way to help people out. And if you need data analysis done, if you need sim coaching, if you need user profiles created where you can use those to coach yourself. I can even analyze data from sim sessions, anything like that. Here's an opportunity to get a low price on what I'm offering and help people in the community that are needing the help. So hope everyone stays safe and take care. And hopefully we'll be through this whole COVID-19 deal soon. Bye.